Hi, in this section we shall discuss different types of matrices. First one is column matrix. A matrix having only a single column is called a column matrix. A matrix is said to be a column matrix if it has only one column. For example, capital A is equal to column wise matrix A, B, C. This is a column matrix because it has only one column. And another one is capital B is equal to column wise XY. In general, A is equal to Aij m by 1 is a column matrix of order m by 1. A is equal to Aij m by 1. M rows by 1 means one column only. Next is row matrix. A matrix is said to be a row matrix if it has only one row. In general, B is equal to Bij 1 by n is a row matrix of order 1 by n because it has only one row. 1 by n means one row and n column. Columns can be many, but the row should be only one. For example, A is equal to 1, 2, 3, B is equal to AB. Next type of matrix is square matrix. A matrix in which the number of rows are equal to the number of columns is said to be a square matrix. That is, number of rows and the number of columns should be same. In general, capital A is equal to Aij m by m is a square matrix of order m. M by m means number of rows m, number of columns also m. Example, capital A is equal to ABCD. This is a 2 by 2 matrix and it is a square matrix because 2 rows, 2 columns, number of rows and number of columns equal. Another one is capital V is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. That's of order 3 by 3. And the most interesting, the least possible ordered square matrix is 1 by 1. Capital C is equal to matrix 7. So this is a 3 by 3 and this is 1 by 1. The least possible case of square matrix. Another one is a diagonal matrix. A square matrix capital B Bij m by m. Why m by m? That is a square matrix. Is said to be a diagonal matrix if all its non-diagonal elements are 0. For example, capital D is equal to, we are considering a square matrix, of course. Here it is of a 3 by 3 square matrix. So there should be 9 elements. And the main diagonal elements, these are main diagonal elements. Except these main diagonal elements, all other elements should be zeros. Means we can fill non-zero elements along main diagonal. Other elements should be zeros. Example 8 is 0, 0, 0, 5, 0, 0, 0, 3. So non-zero elements can be along the diagonal only, that's all. Capital P is equal to 2 by 2 square matrix. Here non-zero elements can be along the diagonal only. Other elements should be 0. For example, 3 and 2, it can be the diagonal elements. Other elements should be 0, 0. So 5, 2, that's the main diagonal elements which can be non-zero. But other elements should be zeros. Next one is scalar matrix. A diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. That is, in a diagonal matrix, all the diagonal elements should be equal. Consider a square matrix and diagonal elements, it should be all equal, k, k, k. It can be a number, we can give say 2, 2, 2. And all other elements have to be zeros because it is a diagonal matrix. So a diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. Another example, you can see 3, 3, 3 diagonal elements and other elements should be 0. So diagonal elements should be equal in a scalar matrix. Next one is identity matrix. A square matrix in which elements in the diagonal are all 1. Other elements should be 0. A square matrix in which diagonal elements should be all 1, 1, 1 and the other elements, non-diagonal elements should be 0. That is an identity matrix. we denote the identity matrix of order n by in. So I3 means 3 by 3 identity matrix 1 0 0 0 1 0 0 0 1. I2 means 1 0 0 1. And I1, can you guess I1? Only 1, matrix 1. So that is about identity matrix. Next one is the zero matrix. A matrix is said to be zero matrix or null matrix if all its elements are zero. Here remember that a matrix need not be square matrix. It can be any ordered matrix, but only one condition: all elements should be zeros. For example, 0 0 0 first row, second row also 0. Simply speaking, all elements 0. Capital B 2 by 2, 0 matrix 0 0 0 0. Capital C 0, like that. Now we switch over to the next one, that is equality of matrices. Two matrices capital A and B are said to be equal. There are two conditions, that is they are of the same order and corresponding elements should be same or equal. That is Aij is equal to Bij for all ij. That's all. For example, you can see capital A is equal to say 2 by 2 matrix 5 7 3 negative 1, and take a replica carbon copy of the same, that is B 5 7 3 negative 1. Now we can say they are of the same order and the corresponding elements are equal, so A is equal to B. That's all. Now example, find A, B, C, D if matrix 2 by 2 A plus B 7 5 A minus B is equal to 5 C D 1. Remember that equality ensures that the corresponding elements are equal and order same. So here A plus B should be 5 and 7 should be C and 5 should be D. Corresponding elements A minus B should be 1. So we have 4 equations. A plus B is equal to 5, C is equal to 7, D is equal to 5 and A minus B is equal to 1. Solving these equations, we can get A is equal to 3, B is equal to 2, C is equal to 7 of course, and D is equal to 5. That's all. Now one question for your homework. Find the values of x, y and z from the following equations. Two parts are there, very simple. You must try only to remember that corresponding elements should be equal. Another question, find the values of A, B, C, D from the equation. Now operations on matrices. Addition of matrices. First of all, why to add matrices, or in which situation there comes the relevance of addition of matrices? And second question, then how to add the matrices? In the month of March, Midun bought 3 pens and 4 pencils, and Radha bought 5 pencils and 2 pencils. Matrix form, capital A is equal to 3, 4, 5, 2. Again, in the month of April, they bought the respective number of pens and pencils are shown. Then, we would like to find the number of total pens and total pencils bought by each in 2 months together. Now, you know that is just to add the corresponding entries, is it? Why? Because corresponding elements means number of pens to be added with the number of pens. Number of pencils in April and the number of pencils in March. So we have to add them. We cannot add a number of pens and a number of pencils. We want to separate total number of pens and pencils. So it's very simple. We have to add the corresponding elements. 3 should be added to 4. Then 4 and 1, 5 and 3 and 2 and 4. You can see 3, 4 should be 4, 1, then 5, 3. 5 added to 3. Now 2 and 4 should be added. 2 and 4 should be added. 2 and 4 should be added. That is simply just add the corresponding elements, that's all. Just add the corresponding elements. This way we can do the addition of matrices. But remember that In order to add two matrices, any condition to be met? Yes, of course, they should be of the same order. Then we can add them how? By adding corresponding entries. We emphasize that if A and B are not of the same order, then A plus B is not defined. For example, here A is a 2 by 2 matrix and B is a 2 by 3 matrix. Their orders are not same, so we cannot add them. We say that capital A and B are not conformable for matrix addition. Not conformable for matrix addition. Now we switch over to the next symbol operation, that is multiplication of a matrix by a scalar. In general, we may define multiplication of a matrix by a scalar as follows. In order to multiply capital A by a scalar K, we have to multiply each and every element of capital A by the same scalar K. For example, you consider A is equal to 3, 4, 1, 5. Take another copy of the same, that is capital A is equal to 3, 4, 1, 5. Now, we can add, we know how to add two matrices, so A plus A. Now A plus A is equal to, how to add? We have to add the corresponding elements. 3 should be added to 3, 4 should be added to 4, 1 should be added to 1, 5 should be added to 5. So A plus A is equal to 6, 3 plus 3, then 4 plus 4 each, like that, 2, 10. So here you can see that A plus A is 2A. So how to get this 6A to 210 in a shortcut way? That is very simple. Multiply every element of capital A by the given scalar 2. So 2A, 2 times capital A, 2 times matrix A means we have to multiply every element by 2. That's all. We can see once again, suppose we have the matrix A is equal to say 3, 7, 2, 5, that's a 2 by 2 matrix. Now, how to find the 3A? I told you, multiplication of a matrix by a scalar means we have to multiply each and every element of the given matrix by the desired scalar 3. So, we have to multiply 3 by 3, 7 by 3, 2 by 3, 5 by 3. Now, answer is 9, 21, 6, 15. Negative of a matrix. The negative of a matrix is denoted by negative A. We define negative A is equal to negative 1A. For example, let a capital A is equal to 3, 1, negative 5x. Then negative A is given by negative A is equal to multiply every element by the scalar negative 1. That's all. Difference of matrices. A minus B is equal to A plus negative B. Negative B means negative 1 into B. That's all. That is A minus B is equal to A plus negative of the matrix B. And negative B means, how to find negative B, negative of the matrix? That is, we have to multiply every element of B by negative 1. That is negative 1 into B. Now another example we are giving, that is capital A is equal to so and so, B is given, then find 2A minus B. How to find 2A minus B? First of all, we have to find 2A. Multiply every element of capital A by 2. Then subtract B from that. It should be homework for you. Find 2A first of all. That is multiply A by the scalar 2 and subtract B from it. That's all. Now properties of a matrix addition. First one is a commutative law. You know that a commutative law in number theory means A plus B is equal to B plus A. In the same way in matrix algebra also, if A is equal to 3, 2, negative 1, 5 and B is equal to say 1, 5 and 7, 2, then we can find A plus B. Also we can find B plus A and we will see they are equal. So we will find A plus B. Then you can see the answer is 4767, that is equal to B plus A. Hence the verification of the result. This property is called a commutative law. Second is associative law. For any three matrices, of course, there should be conformable for addition. then a plus b plus c is equal to a plus b plus c. A plus b plus c is equal to a plus b plus c. So a is equal to negative 1572, b is equal to 1 minus 105, c is equal to 1234. Then we have to verify the associative law. How to do it? We have to find a plus b first of all, then add c with that. Secondly, we will do b plus c first of all, then add a to that. In either case, we will see answer same. So a plus b plus c is equal to a plus b plus c. This way you can verify. You please complete the work. Now, existence of additive identity. Let a capital A is equal to Aj be a matrix of order m by n and OB a zero matrix of the same order. Then we can verify a plus O is equal to O plus A is equal to A. In other words, O is the additive identity for matrix addition operation. So 19570 plus 0 matrix is same matrix 19570. Similarly, 0 matrix added to any matrix. Answer is same the given matrix, that is 19570. That is why a plus O is equal to O plus A is equal to A. Now, existence of additive inverse. Let capital A is equal to capital A Aj m by n be matrix. Then we have another matrix as negative A. We already discussed about negative A. Then we can find A plus negative A is equal to negative A plus A is equal to O. That is 5, negative 2, 3, 7 plus then negative of it. That is negative 5, 2, negative 3, negative 7. You can see that the answer is 0, 0, 0, 0. A plus negative is equal to, what's the answer? That is 0, 0, 0, 0. That is O. So A plus negative A is equal to negative A plus A is equal to O. Here negative A is called additive inverse of capital A. Now we will see some properties related to scalar multiplication of a matrix. If capital A is equal to H and B is equal to BHA, we can see that there should be of same order. Then K times A plus B is equal to KA plus KB and K plus L times A is equal to KA plus LA. For example, numerically 3 times A plus B is 3A plus 3B. Also 3 plus 2, 3 plus 2A is equal to 3A plus 2A. Thanks for watching. We will come with new topic in the next class.